Hello everyone. Today I'm gonna talk about single phase and three phase, which is obviously my topic is the power, and I'll start with the three phase transformers. There is two types of three phase transformers. The first one is they call it the three phase transformer bank composed of independent they be like independent transformers. And the second one is the three-phase transformer like wind on single three legit core. Here you can see there is like four possible configurations of transformers for the three-phase transformers connection, like how you connect them. There is a YY here, and there is delta Y, and there is delta. There is Y delta, delta Y, and delta delta. I'll I will explain it later how they connected. Uh, we need for in order to solve to find the connection. Here you see like the connection of how they connect like the Y delta. As you can see here, this is uh, the primary, and this is the secondary. The secondary, which is delta, and the primary, which is Y here. And as you can see, the dot here, 1, 2, and here, 1, 2, and you connect it to the secondary. So the voltage of the primary over the voltage of the secondary is going to be equal. After the calculation, it's going to be equal to the square root of 3 multiplied by a which is 1. For the second one, this is delta y, and this is how it's connected. This is the primary, and this is the secondary. And after calculating the voltage of primary over the voltage of secondary equal to the n number of coils in the first primary the primary transformer over the square root of 3 multiplied by the secondary number of coils. Third one is the delta y. See how it's connected, and as you can see, the difference is gonna be between this one I'm sorry, this is the delta delta. It's gonna be just n primary over n secondary equal to the V, the voltage of the primary transformer over the voltage of the secondary transformer. And here's the last one, the YY connection. As you can see how it's connected. This is the primary. Just focus on the dots. The dots is very important here. Check how it's connected. They're all connected in one dot. You see this dot and this dot. And same thing here. NP over NS, so the same thing is gonna be for the dot YY connection. For the next one, I'm gonna talk about the single phase transformer. There is some consideration we gotta take. Like these are facts we need to take must be considered. If you look at the non-ideal, if you look at the ideal single phase transformer, as you can see, there is a couple losses in the primary and secondary units, and there is a small fraction of flux leaks outside the core, passes through winning. Here's some explanation here for the single phase. This is ideal transformer. And here's this model referred to the secondary. The first one at the top is the primary, and the second one is the secondary. And I have some questions to solve some practice problem. Here's the first one. It's just assume three-phase Y-connected synchronous generator operating with a lagging power factor. Just focus on the lagging power factor load. When the load is decreased, describe what happened to the following variables: magnitude of the generator's internal generator voltage, phase, angle on of its internal generated voltage. The answer is A. The magnitude. What's happened to the magnitude and what happened to the phase? So the magnitude is going to stay the same in this case, and the angle decreases. In this case, for the armature current, the answer is B. The magnitude is going to decrease. The phase angle stays the same. For the third one, the magnitude is going to increase and the phase angle stays the same. Just review this question and let me know if you have any question. I have this is just this is my source for my Professor Young. I got a question. Thank you very much for listening.